Hello everyone. In the previous session, we discussed templates and how we use them to onboard our CH devices, resulting in a full mesh overlay network. We also talked about OMP, the OMP protocol, which is proprietary to Cisco and runs in SD-WAN, being the only dynamic protocol for routing information exchange. Today, we'll discuss manipulating topologies via the control plane. We need to tailor our topology according to the actual project requirements, transforming our topology from full mesh to, or rather, reconfiguring it into a hub and spoke topology. To achieve this on the control plane, we will be using policies. There are two approaches to learning policies. The first is to understand the principles of policies before applying them, and the second is to start with hands-on examples, master the changes in topology, and then delve into the principles. Alright, I'll use the second approach for our discussion. By manipulating our COB VPN and employing a policy named PCI VPN. Once we understand the process of policies, we can then study the principles behind them. When we aim to manipulate through the control plane, there's a crucial step which involves transitioning vSmart to managed mode. What does this mean? Essentially, it's about transitioning vSmart from the underlay network to the overlay network. This is something I prepared in advance and executed using templates. Here, we need to review the templates and switch to our lab environment to review the templates we created earlier, including the ones related to device platforms. All templates related to vSmart are here. These are featured templates created separately, which we then invoke in the device templates section. Let's do a quick review. Here we have system templates, NTP templates, similar to those in CH, and an OMP template as well. There's a VPN0, an underlay with a management one, and a VPN 512, almost identical. Alright, during the operation process, let's look into a detail. How to configure the parameters for our vSmart. Here we can see some parameters were configured through a template. You might notice these parameters are almost identical to the underlay parameters, with little variation. Here, this isn't the challenging part. This is our topology suggestion. Before attending the session, everyone should print it out. So when I mention a certain site or IP, you can quickly and easily locate it. Today we will conduct a series of operational tests. We will transform our PCI VPN into a hub-spoke model. Basically how our traffic flows. Please observe our topology diagram. Our test point is at BR2. In the default scenario, between our BR2 and BR1, they can communicate directly with each other. At this point, we need to test in the experimental environment. After being configured into a hub-spoke, BR1 and BR2 cannot communicate directly. It's not possible. We require their traffic to pass through DCC CH1 or CH2 to access BR2 again. DC is the hub point, managing the round-trip traffic. Traffic goes up to the hub, then comes down to BR2, which can be understood. The basic configuration idea here involves these three modules. Before operating on the topology, we must have a clear understanding of the current environment. A pre-check is necessary. After completing the check, create a policy. Then, activate the policy and push the configuration to the devices. It's disseminated through vSmart. Once implemented, conduct a ping or tracer test. If unsuccessful, we need to troubleshoot. to eliminate any faults during the configuration process. Now, switching to the experimental scenario, start with the policy. Emphasizing the importance of this topology again, everyone must be familiar with this topology. First, we check the communication between BR1 and BR2. The communication between these two sites. In the monitor menu, we are now logging into BR2 device to troubleshoot using 4.4.4.4, performing a trace, tracing from BR1 to the test server, the test terminal. The current VPN for 20.101 has an ID of 10. Selecting an interface, next hop. 20.3, look at the topology. You can see point 3 at this location, 20.3. This means the two devices communicate directly, direct communication, without going through any other sites. Next, let's look at the policy. This policy I've already created in advance. We can edit it. In this policy, how is it implemented? The policy name I used is HS_PCI_TLOC. Let's retest here. PCI is the VPN. Let's retest with 20. Our test object is 22. The VPN number is 20. Point 3's path is the same. See, only the test destination IP has changed. Now let's observe the policy name HS_PCI_TLOC. Within this policy, how do we implement the hub-spoke operation? Here we first do a view. When our BRs have an outbound direction, how do we handle our routing? Next hop is actually similar to our policy routing. Specifically, where is it? We edit it like this, editing our topology. There was also a question about a representative, a list called BR. Let's take a look at the list. All of these need to be prepared in advance when we are making our policy. They need to be predefined. There needs to be an overall plan so we can configure the site list in advance. This makes it convenient for you to easily reference it when needed. Look, this DC list represents 2 data centers and the BR list represents 2 sites. Sometimes we need to separately call DC, representing DC1. The site ID number cannot be wrong, nor can it be something else. If you intend to call the site DC1, its site ID is 100. BR12 is the same, this is the site list. Then we also have a VPN list, 2 VPN lists. Okay, there's also a TLOC. We often say TLOC actually represents a router emitting a route, including its label. It's at a specific physical geographical location. Here I've created a list for TLOC 1.1.1.1, okay, meaning C Edge 1 has an internet line, C Edge 1 also has an MPLS line. The corresponding 2.2.2.2 has internet and PLS. After understanding these lists, let's look at the topology again. Find this name, CI TLOC. This name, within the PCI TLOC policy, I added a route entry. The premise of this route entry is to meet the conditions of the BR list, meet the PCI VPN, list name VPN20. When this number is met, what action do we take? We specify the next hop, directing their next hop towards the DC. Let's observe the topology diagram. When BR1 and BR2 have their destinations pointing towards the DC, it means we've diverted the traffic to the DC. In this case, the 2 BRs will no longer communicate directly. Their traffic will go through the DC, ensuring all our traffic is routed through the DC. No problem. Okay. Regarding other traffic controls, similar to access control list entries, the last entry defaults to denying all traffic. We only expect to match traffic from VPN to 0, which needs to be processed. We don't care about other VPN traffic. So the final statement is to acknowledge and allow passage. This means to allow passage. This is our policy. Before activating this policy, we have another point of observation. We just did a pre-check. Now we'll do a second check. On the command line, observe the routing on the fourth router. The place we just tested is heading towards destination 20.0. Its next hop is 3.3.3.3. Understood. When we implement the policy, after the policy is successfully activated, we observe its routing table again to compare before and after. Wait for the policy to be propagated. Once the policy is successfully updated, observe the routing again. Heading towards destination 20.0. Where is the next hop now? It has changed. This is very important. It proves that our policy is effective. Okay, do a route tracing again. We can clearly see our path first reaches 172.162.0.2. Where is 202? In our topology, 2LZ to a disposition, CH2, correct. It has reached the headquarters. Where is 30.3? 30.3 is our BR1. At this position, it is 3.3, meaning the traffic perfectly meets our requirements. Where does our traffic go from and to? It follows this path and then reaches our BR testing point in greater detail. Note that 20.2 is the MPLS line. Pay attention to 30.3, which is this line. That is, the traffic going to DC is via the MPLS line and the returning traffic is via the internet line. We will adjust this point in subsequent courses. How to dynamically and automatically select routes based on latency and jitter. Alright, this is our second checkpoint. Now, we have understood the strategy and have applied the strategy. Using test commands to trace our data flow path, we found that it meets our hub-spoke requirements. This is a common operation in a hub-spoke topology. Alright, please pay attention, because earlier I have prepared the strategy in advance. The strategy I made is this one. Strategy you all can understand. Apart from being a test point just now, in the testing environment, we observe in the topology. We also saw the test points and the test machines with the help of today's lesson in our entire topology. Test points and test machines are also introduced to everyone. Here I have 3 test machines. The first test machine is DC1 PC. How to set up the test machines we need in practice. You can use any Linux host, which has multiple network cards. One of the network cards represents our VPN service. This is for out-of-band management. When it represents VPN service, this card represents PCI VPN, as you can understand. We have a default route. There is a default route which carries VPN 10. Additionally, you can see 2 static routes which carry the traffic for VPN 20. Similar to this, let's look at the BR test machine. The basic idea is to assign a network card with a default route and use 2 static routes to forward traffic for other networks. This is very important. Of course, you can use multiple test machines, but here we have simplified it, using fewer devices to simulate more tests. A default route. Assigned to VPN 1.0, 2 static routes are given to VPN 2.0. Earlier, our test point was at CH4, representing BR2. Similarly, here we can use the ping command to test VPN 1.0 and 20.101, no problem, you go and trace. First it goes through the gateway 20.3, then 20.101. Passing through 20.101 is essentially 2 hops. Don't worry if you didn't see the TLOC information. This is due to IPS encapsulation. TLOC is not visible in the command line, but in our overlay, this is more evident. Alright, today we discussed PCI operations. Our next video will cover Corp VPN operations and adjusting VPN membership relationships. This video ends here.